We are moving on to the last sessions of our chapter, frames of reference, and we have discussed the non-inertial frames and the pseudo force acting in non-inertial frame is Coriolis force and centrifugal force. Now we are going to specifically examine the effect of Coriolis force on the surface of the earth. If you assume a body on the surface of the earth is in motion, like it could be a freely falling body, it could be wind, it could be flowing water on the surface of the earth. With respect to earth, in an ideal case, we assume earth to be an inertial frame. But actually, what is earth as far as a frame? We are attaching a coordinate system to earth. Earth is rotating in its own axis and it's revolving around the sun. Means it is what? Rotational motion indicate accelerated frames. So basically, earth is a non-inertial frame. So normally a body which is moving with a velocity v on the surface of the earth will experience a Coriolis force, which is given by the expression which was discussed in the last class, given as minus 2m into omega cross v. We can write here Coriolis force F is equal to F is equal to F is equal to minus 2m and mass is a scalar and omega angular velocity, omega cross v, and both this omega and v are vectors, omega cross v. And this is the expression for Coriolis force which we have discussed in last class. Now we assume, and next we assume basically a coordinate system. It's like I can express my coordinate I can express my coordinate system as if I'm drawing a line like this way, and I have to put arrows indicating the directions, and this is east, this is the east direction, this is south, this is north, and this is west. And I can have I cap here, unit vector I cap indicating the east direction, and j cap indicates the north direction. Okay. Now what we assume that a body is falling freely, vector v. I'm going to represent vector v to be vector v is equal to minus v, velocity of the body which is falling freely, which is falling in the downward direction represented by the negative sign, and it is in which direction? It is in kth direction, that is I, j are represented in this plane and k will be perpendicular to this plane in a normal case. Okay, so this is a problem. A body is falling freely downward direction along the z direction. If this is x, this is y, and normally the perpendicular direction will be the z direction or z direction. And k is the unit vector along the vertically upward direction. And it is understood that it will be this direction. If this is the plane of the paper, it will be perpendicular to the plane indicating the vertically upward direction, and minus k means downward direction. Positive k is the vertically upward direction, minus k indicates the downward direction. Okay, and I'm going to represent it pictorially, right? I'm going to represent it pictorially. Okay. Okay. Just listen. Just take out your note and draw this along with me, so the things will be more clear to you. It is not that difficult, but still it will be a bit confusing if you're not following. Okay, and I'm just drawing the north-south direction, right? And here I'll assume, okay, and I can put the arrow marks here. I can put arrow here, and this is north direction, and this is our south. Okay, and what happens here? This is our earth, and it is rotating in its own axis, and normally at any particular point it will be having an angular velocity, right? And what I'm doing here is I've marked my north-south direction, and mark my vertical. I'm going to mark my vertical direction. Vertical direction is what? Z direction, and that Z direction is what? K. That Z direction is K for you to identify. I change the color. This is the vertical direction. This is the vertical direction, and we are naming it as K. This direction is K. Okay. And right, and this the body is falling freely along vertical K. Upward direction is positive K, and downward direction is negative, and it is falling freely in the downward direction, and its velocity represented by minus v into K cap, which is the magnitude, and this minus K represents its direction along downward direction. And I can just mark this angle. Actually, I cannot use this symbols and all here either. I have to copy it from Word. For the sake of simplicity, what I'm doing is representing my theta to be Q. Okay, bear with me. I'm representing, okay, or I'll use this. Okay, I'll use this angle, or instead of Q, I'll just write this as phi. Okay, don't get confused. This is the angle phi, and what is written next is, suppose this is the R is to be the radius of the earth, capital R, and if I'm drawing a line which is parallel to this red line, what happens? I'm drawing a line which is parallel to this radius. What this angle is phi. Naturally, this angle also will be what? Phi, right? No issues. This angle will be phi, and I'm having my angular velocity. Since Earth is rotating in this direction, its axis of rotation is this. So I'll have the I'll have the Earth rotating with the angular velocity omega, and that will be in this. That will be in this direction. Okay, that will be in this direction, and I'll name it as omega. It is actually vector omega. I'll name it as omega. I've named it as omega. So naturally this angle will be 90 degree. This total angle will be 90 degree. This is phi means, what is this angle? This angle. Yes, that's right. It is by the it will be 90 minus phi. It will be 90 minus phi. I have notated it as 90 minus phi, right? And what is this direction? This direction is vertical direction. I'll just put a text there for you to understand. It is vertical direction. I'll put a text here. This direction of K is vertical direction. Vertical direction. Okay, it is vertical direction. This is the vertical direction. Okay. So, what's next? Here it is. K, which is Z direction, and here I'm having J direction. Okay, I'm going to represent J also here. J. This is the J, the direction. Okay, and this is J. Unit vector J, and it is indicating the north direction, right? I'm having J there. Okay, so that's all. So what's next is, this is omega. So naturally, if you are just solving the components of omega, what I'll get? This is 90 minus 5, this angle, that is omega, making with the k direction is 90 minus 5. So I can resolve omega to be, I can resolve omega, right? I'm going to resolve omega here. It's like omega. What I can write? Omega is equal to, this kth component will be the cos component, and jth component will be the sin component. That is, omega is equal to, I can write it as omega cos 90 minus, I cannot use phi here, so I just put it as q. Okay, instead of phi, what I'm doing is putting it as q, and it is what? Omega 90 minus phi, it is along k direction. And what's next? Plus omega sine omega sine 90 minus phi, and it is along j direction. It's not x, so omega 90 minus phi, and it's along j direction. It's unit vector. I cannot use that notations and all, so please cope up. It is omega vector omega. Omega is equal to omega. It is scalar. This omega is vector. This omega is vector. Okay, this omega is vector. Omega cos 90 minus phi k cap plus omega sin 90 minus phi j cap, and k and j are the unit vectors. So what is cos 90 minus phi? So cos 90 minus phi sin phi and sin 90 minus phi. Just get reversed, right? So what I can write? So I can write it as omega is equal to omega cos q cos 90 minus phi, it will be j, right? Plus omega sin q, and sin component will be the kth part. Okay, I'm simplifying it. So this is what you're going to get. That is, I'll write it here. It is omega, that is vector omega is equal to magnitude part is what? Omega cos phi, omega cos phi j plus omega sin phi, omega sin phi k. Okay, omega cos phi j plus omega sin phi k. Okay, so J is the unit vector along the direction of north and I is unit vector along the direction of east. Right. So I have already the expression for Coriolis force. Coriolis force is what? Coriolis force, I'm having the expression for Coriolis force as F is equal to minus 2m omega uh, okay, F is equal to minus 2m omega cross V. Right. Now what I'm doing is I have to substitute for omega and V. Substituting for omega, what you'll get? Substituting for omega, you will get F is equal to, hope you're writing along with me, F is equal to minus 2m, and instead of omega I can write what? Omega cos phi j plus omega sin phi k, and what is outside? Outside I'm having cross V is what? V is minus V k. Cross minus V k. So it is what? J cross k. J cross k is what? I. And here we are having a minus sign. And here also we will having a, here is a minus sign, here is a minus sign. And here what is that? 2m omega cos phi j cross minus vk. So normally j cross k, I j k. J cross k is what? I. And minus into minus plus. So what is left? And here what is the thing is k cross k. K cross k is 0. And I'll show it here. J cross k is equal to I, and k cross k is equal to 0. Vector cross products. That's what's happening in the vector cross products, and you might have studied it in maths and all, and you might have studied it in your physics classes also. So what happens is that the k term vanishes and j cross k become I. So our force become force is equal to, what you'll be getting is 2m omega in V cos phi, and j cross k is I, and I cap. Okay, so this is the expression that you're going to get. This is the expression 2m omega V cos phi I. Okay, so it shows that only horizontal component of Coriolis force affects the motion, and this act in which direction? I is towards east direction. So the Coriolis force acts on a freely falling body towards the east direction, and it represents actually what? The right direction. It represents the right direction. Because of this reason itself, the eastward horizontal constant force is acting on a freely falling body, which deviates its path from its vertical path towards the east direction. So this is the pseudo force which causes the eastward deviation of freely falling body in the northern hemisphere. Okay, so hope this derivation and this concept is clear for you. Okay, and what I'm doing here is I'm just showing you as some parts. Okay, so these are the things that we discussed so far in this class. Actually, Okay. So this heading is sometimes it won't be that clear for you. Effect of Coriolis force on flowing river or wind. The heading of this topic is, please note this down. Effect of Coriolis force on flowing river or a cyclonic speedy wind. Suppose we assume the river is flowing or wind is moving. In which direction? J direction represent our north direction. I've shown you before. J represent the north direction. The coordinate system shows. And the expression for Coriolis force is what? Minus 2m omega cos phi j plus omega sin phi k. And if you're taking the cross product with respect to the direction of the wind, which is in the northern hemisphere, wind which is moving horizontally towards northern hemisphere. So normally J cross J is 0 and K cross J, K cross J is what? Minus I. You should remember IJK represents the cyclic. Cyclic rotation happens. I cross J will be K and J cross K will be I. K cross I will be J. And here what is that? K cross J. K cross J means what? It will be minus I. So what is happening? Minus into minus become plus. So this J cross J becomes 0 and K cross J becomes I. So what will be left is minus into minus 2mb omega sin phi I. And this I represents eastward direction. J represents north, I represents eastward direction and K represents the vertical direction. Okay. So what's happening here? This shows that the river or wind deflect towards east or it is towards right. And this is north, this is south, this is east and this is west. Deflection towards east means what? What's happening? A wind which is flowing in the north gets deflected towards east. East means it is right direction. I represents right direction and minus I represents the left direction. So this shows that the river or wind deflect towards the right if phi is positive in the northern hemisphere, and the phi is negative means in the southern hemisphere deflects in the opposite direction, that is towards the west. Because of this effect, it can be observed that the cyclonic speedy winds they are turned towards their right in the northern hemisphere and towards their left in the southern hemisphere. So just listen to me. This is a sure question for the exam. Why the wind gets turned towards right in the northern hemisphere and towards left in the southern hemisphere. So this is how you are going to represent it mathematically. And there is one more question, expected question. And this also explained why the right banks of the rivers are eroded in the northern hemisphere and the left banks of the rivers are eroded in the southern hemisphere. Right banks are for the rivers get eroded in the northern hemisphere and the left banks of the rivers are eroded in the southern hemisphere. It's again a question, and for the same reason the rivers in the northern hemisphere bypass all kinds of obstacles in the right, and a river which is flowing in the northern hemisphere gets all the particles, or it gets the short portion in the right direction in the northern hemisphere and the left directions in the southern hemisphere. It removes all like particles or obstacles in the rightmost part of the river. And Coriolis force on moving particles. Okay. In the northern hemisphere, it's not needed. In the northern hemisphere, where omega points out of the ground, the Coriolis force is 2m omega cross tends to be. Okay, that's something that you already know. So keep in mind, in the northern hemisphere, the force will be towards right, and in the southern hemisphere, it will be towards left. And the same case is happening for winds and for rivers also. So I'll send you this PPT and I'll send you some links which makes the things more clear for you by animations and all. You just go through that links, so things will be more clear for you. Okay. So we'll discuss some problems. Okay, in the next video, we'll discuss three problems, and I'll give you some assignments also. Okay, so with that, we are going to come to an end of this chapter by the next class by discussing some problems and by assignments. And what is next is you'll have to prepare for your exams after the autumn vacation. That is frames of reference. Study frames of reference well and prepare well during your autumn vacation. Towards the opening, there will be an exam, and I'll send you the links of the classes on relativity and conservation of energy. I'll prepare it. I'll send it in a bunch, and I'll give you time for study. Okay. So I'll send the links also along in this class.